Hello everyone, so now we are going to do one more lab. If you remember, in our previous class we done ACL, standard ACL we use. Now we are going to use the extended ACL. We are going to learn how we can apply, like example, if your manager asks you, this guy should not access the server but he can access other services. Example, maybe your manager told you this guy should not access the web services but he can access the other services, like he can do the telnet but he should not able to do the web browsing, something like that. So how we can do, we are going to learn. So let me create one small scenario. In that one we are going to do. So let me take, this is a R1 and this is a R2. We have the two router. Okay, already we have the idea about this one, but anyhow, because we are going to do the big lab, so before going to that one we should have the basic idea how we can perform that one. So for that purpose I am using this one. I have two router and also I am taking two switch. We will have a small scenario. Imagine this is your small organization where you have the switch 1, switch 2, and it is having two router, it is connected. So this is a basic topology I am making here. After that I will give you the scenario. If you can do, if you cannot I will teach you, no issue. Okay, so I have two computer here. Let me take some server here, one more server here. Okay, so now let me connect this to this machine from here to here, from here to here, and from here to here. And let me decide the IP schema. Here in between them I am going to use 1.1.1.1. okay, this side let me move this here. This side will be 1.1.1 and the other side I am going to use the 1.1.1.2. You need to remember they should be in the same network, else they cannot communicate. Directly connected router should be in the same network. Okay, so this is the IP we are going to assign to this interface and this is IP we are going to assign to this interface. Okay, and here this is our LAN area. Let me keep like this. This is the LAN area. I have this port and here also my LAN area. I have here 3 PC. Okay, so IP schema, this side is okay. LAN side I will use the 192. Okay, let me write here 192.168.1.1/24 and this side I will use 192.168.2.1/24. This is a LAN side IP and WAN side is having 111. Imagine like that way. So your manager told you, example, this is a server. Imagine this is a SRV. I am writing in the shortcut. This is a server. Your manager give you assignment saying that this PC is 0 or PC1. We can give this name as a PC1 and let me write IP. We are going to use this IP to this PC1.2. So your manager told PC1 should able to do the ping but he should not able to do the telnet or he cannot access the web browsing. We can define in our own words. Let me give you a small scenario. Your manager told this is a PC1. PC1 should not access the port 80 of this server. Okay, port 80. If you remember, 80 is nothing but HTTP. 443 is HTTPS. Okay, so your manager told deny the port 80 to this PC. Deny the port 80 to this PC. Other services he can access. Same thing if he told for the PC2 also we can do, or he can give any other activity also. So no issue. Now we will take only one activity. As per your manager, the PC1 should not access the port 80 of the server. So we need to block the port 80. You need to remember port 80 is nothing but HTTP. Okay, HTTP is a port 80. HTTPS is a 443. You need to remember this one because in the coming classes we are going to use this one. Port 80 is nothing but HTTP. Port HTTPS is nothing but 443. Anyhow, as per our manager, we need to block the port 80. Before going to that one, we need to configure the basic stuff. First, we need to assign the IP. So and make the connectivity between them and then perform the ACL. So let me go here. I will go here. What I will do here, let me see here. Let me do here. First I will write no here. Okay, this is my R1. So let's me do the configuration. I go in the configuration, I will change the name as a R1. After that I need to assign the IP. I am going to the interface fast Ethernet 0x0 IP address 1.1.1.1 255.0.0.0 and I will write no shut. So this way I assign the IP to the interface fast Ethernet 0x0, this one, and now I am going to assign to this one. So I will write interface fast Ethernet 0x1 IP address 192.168.1.1 255.255.255.0 and I will write no shut. So this way we assign the IP address, and we need to enable some routing protocol because we need to exchange the route, because our route, if you see here, let me show you, this is the our LAN network. This will not go to this router. This router will don't know anything about this one, and this router don't know anything about this one. For that purpose we need to run any routing protocol. We can do static routing, default routing, or we can do what we can say dynamic routing. So as we are doing all the time OSPF, in real scenario also we are using OSPF most of the time. So let's do the OSPF. So OSPF, I hope you already know this one because we learn. So let me configure the OSPF. So how we will do, we will write router OSPF1. Okay, then I will put the interface fast Ethernet 0x0 IP OSPF1 area 0. I am doing very fast because already you know how to configure. That's why I am going fast. If you face any issue, WhatsApp us, we will support you. Okay, I am going to enable on other area also. If you see, I enable OSPF on this interface and also I enable OSPF on this interface. So now our OSPF configuration is done. I want to save the configuration, so I will write do WR. Because I am here in the configuration mode, so I will write do WR. WR is for saving the configuration. So R1 configuration I finished. Let me do the R2 configuration. So this is the brand new router. I will write here first to no and then enable, then config t, host name is R2, as this is a R2. Then let me check what is the interface IP here, so we can assign fast Ethernet 0x0 is 1.1.2. So I will write here interface fast Ethernet 0x0 IP address 1.1.1.2. okay, and then 255.0.0.0 and I will write no shut. One interface finish, another interface, let me check, this is a F0x1. So let me assign here also interface fast Ethernet 0 F0x1 F0x1 IP address, I will write here 192.168.2.1 255.255.255.0 and I will write no shut here. Okay, and I will enable the OSPF router OSPF1 interface fast Ethernet 0x0 IP OSPF1 area 0. I am using area 0. Area, let me correct here, area 0, and then interface fast Ethernet 0x1. okay, IP OSPF1 area 0. So this way I enable the OSPF. Now we can check routes are coming or not. So I will write show IP route OSPF. Show IP route OSPF. Still I am not getting the route, so it will take some time. Meanwhile we can check here, we perform IP, everything is correct or not. Let me check here also. Show IP interface brief. I have the IP, okay, 1.1.1.1 and this is okay, and up show IP route OSPF. Now I have the route. Okay, I am here in the R1. If you see here, I am here in the R1 and I am getting this route. Okay, let me show you where I am getting. If you see here, or let me move this up. Okay, you can see here, this is the route. I am here in the R1. I am getting that 192.168.2.0. This is a 2.0. This network means here I am getting, if I want to forward the traffic, I need to forward to this IP. This IP belongs to this interface, and this is the AD value. This is a metric, and this is the uptime, and this is the living interface. Okay, so I hope this is a clear. Now everything will work perfectly. Then we are going to perform the operation. So let me assign the IP to this server, so our team can ping this one 192.168. What IP shall we give to server? let me give 2.2. okay, this is the server IP I am giving, and the gateway will be the router IP, so 2.1. okay, so this IP is okay. Now let me try to communicate and check from here. I am going to my computer, I am going in the command prompt, I am going to check do I have IP or not. I don't have any IP, so first of all I need to assign the IP. I will go to my machine, I will assign here 192.168.1.2. okay, and after that let me check what I done, something incorrect, 192.168.1.2, and then I will write the gateway, subnet mask, and then gateway will be 1.1. so 1.1 is a gateway. So now my machine is having the IP address. I need to check I can access the server or not. okay, so this is my server IP, ping 192.168.2.2 is the server IP. Let me check what IP we give to server. We give this IP, so let me put here. okay, this is the server IP, so easily we can remember by seeing the server. So if you see first first request is dropped because of the ARP, address resolution protocol, so no need to worry for that one, and after that it is working. I can ping. okay, now let me check I can access the port 80 or not. If you see, I will write here 192.168.2.2. okay, I can access the port 80. How I know port 80? Because this is HTTP and I am not writing S. If it is not S means HTTP. HTTP is nothing but port 80. If I put HTTPS, okay, if I put HTTPS, that is a 443. This server is enabled both port 80 and also what we can say port 443. Let me show you. This is the services in the server. I will go here in the, this is the web server. If you see, HTTP is enabled, port 80 is enabled, and also HTTPS also enabled. This is a 443. Let me off this one. okay, so now let me check. If you see HTTP, let me close this one. I will write here, I will go here, I will write 192.168.2.2 and I will press enter. If you see, I am able to access the website, but if I put here S, because I disable that one, so what I will do, let me close this and open again. I will put the HTTPS and I will press enter. If you see, HTTPS is not working, that is port 443 is not working. Why? Because I disable here. So now let me enable this. okay, I enable this one. Now if I refresh, it will work. HTTPS, that is secure socket 443 is working. So perfectly everything is working. Now we need to block this guy. He should not able to access the port 80. Port 80 means you will, when we will ping here, when we will write here without S, it is working now, but we need to do that without S. This should not work. okay, so we can use the extended ACL. so you remember, I hope, whenever we are doing the extended ACL, we will apply the ACL near to the source. So source is nothing but this guy. This guy is a source and this guy is a destination. This is a destination, this is a source, so we need to apply the policy in this router. okay, so let's do here. What I will do, I will go here inside the router. This is my router. I will write here access. First of all, I will go in the global configuration mode and then access list 100. If you press question mark, if you want to use the standard, then 1 to 99. If you want to create the extended, then 100 to 199. So I need to create the extended, because in extended we have more options. So I will use the 100 and then I will say deny. What I need to deny? TCP. okay, from which host? Host means from which computer? This computer. So I will say 192.168.1.2. okay, deny for this computer. Going to where? Going to host 192.168.2.2. okay, equal to port 80. Let me explain what I am saying here. I am saying access list 100, deny TCP protocol for this host. Which host? This our client, this machine, accessing to the other host, that is, this is a server IP. I am saying when this guy is trying to access this guy by using the TCP port number 80, deny. I am saying like this. When this guy is trying to access this guy by using the TCP protocol at the port number 80, block that guy, not allow them. Okay. So I wrote like that. After that, what I will do? I will press enter. Okay. I press enter. What else I need to do? Nothing. But by default, ACL is deny. Okay. If I did not write anything, it will deny. By default, ACL is having the deny statement at last. ACL is working from the sequential from top to bottom. So here we told deny, and at last by default we have deny. So they will deny only. So I need to say permit all. So what we will do for that purpose, we will write here access list 100, access list 100. Okay, permit IP any. So I will say permit any IP. First check this one. If this condition match, block that guy and permit all other guys. That's all. We created the ACL. Now we need to apply. First thing, we need to create the ACL. Second thing, we need to apply. So now we need to apply. Where we will apply? We need to apply to the interface port. So if you see here, where is our interface port? This is our interface for port F0 by 0, or we can apply here F0 by 1. Our wish, wherever you want, we can apply. But condition is like whenever we are applying to the inside, like if you are applying here fast Ethernet 0 by 1, we will write in. If you are applying here fast Ethernet 0 by 0, we will write out. Anyhow, let me show you how we will apply. So we need to apply under the interface, right? So now what I will do, I will write here, I am going to apply to this interface, fast Ethernet 0 by 1. So first I need to go in that interface. So now I am inside that interface. I will write IP access group, and what is the number we use? We use 100. If you remember, this is 100 we use. So same number we need to write, IP access group 100, and traffic is going inside or outside. You need to check. If you see here, this traffic is going from here to here. Traffic is going into the router. Okay. If you see this interface, traffic is going into the router. If you see this interface, traffic is leaving, that is going out by using this interface. But if you see this interface, traffic is going into the router inside. That's why we need to write here in. If you are writing this interface fast Ethernet 0 by 0, if you are applying in that interface, then you need to write out here. Okay. I hope this is clear. Let me write now in. So let me go here and I will write here in. Okay. So I apply. What I done, first I create the ACL, then I apply the ACL. Now let me save that one. WR is for save. Now we can check before it is working. So now it will not work. I will go here. I will press here. Let me remove HTTPS means port 80. Now it will not work. If you see, nothing. After some time you will have request timeout. Some issue will come here. But if you put here HTTPS, it will work. Okay, let me show you. It will take some time. After that it will have the what we can say request timeout option will come here. So till that time we can do one more thing also. See, request timeout came here. But example, if you put here S, that is port 443, and press go, it will work. But when you remove this one, that is a port 80, it will not work. Okay, port 80, it will not work. Let me show you. Again click this one and put this is a port 80, it will come request timeout. But if you put HTTPS, it will work. Okay, I hope this is clear now. Only we block the port 80. He can ping, he can do whatever other option. Okay, request timeout. But if you put S here, it will work. Just now what we check. So this is working for port 443. Other ports are blocked. And if you want to ping, you can ping also. Let me show you. Ping 192.168.2.2. It will ping. Ping is working, but he cannot access the port 80. And if you want to check also, you can write telnet port 192.168.2.2 and port we are saying 80. 80 will not work. Okay. If you see 80, 80 will not work. You will have the connection loss like this. But if you put the port 443, 443 will work. Let me see. The connection timeout remote host is not responding for port 80. If you check the port 443, it will work. Port is open means port 80 is working. Okay. So I hope this is clear for you. If you see, let me show you. Port 443 is working. Open means working. And if you put here port 80, it will not work. So as per our manager request, we block the port 80 for this PC1. Okay, we learn in this lab. In the coming lab, we will do some more labs. After that, we will go is NAT. After finishing the NAT, we will do small organization network. Then we will go for the big. After that, we can go for the big organization network. Okay, thank you. See you.